All right, we're going to be talking about inequalities. An inequality is a statement, just like if I had an equation like a plus 2 is 3, that's an equality. That means this side, the one side of the equation has the same value as the other. An inequality just means exactly that. One side is not equal to the other side. One side might be more, one side might be less than another. They are not exactly equal. One side has a greater value than the other. So those inequality symbols we would use this one. This side is greater than. I always read the sign going this way. Left to right is how we're reading things. So this is greater than this. Then I have the less than. So this would be less than the other side. Again, I'm always reading it right to left. One thing I could have is I could have this symbol, which means greater than or equal to. Sometimes I'm not sure. I know it could be greater than or equal to, or I could have this symbol, less than or equal to. So what are some words that might be more than? Okay, I might actually read those words of this was more than this is less than this. I might see words like, what would be something that would mean greater than or equal to? What would be another phrase I might find?
Greater than, equal to, or equivalent.
If it's equivalent, then it is exactly equal. But what if I had a word like at least? I say you are at least 10 years old. That means you could be 10 or you could be older, right? So those words like at least would still mean greater than or equal to. What are some words that would mean less than or possibly equal to? Maybe we can't think of them right now. Maybe we'll kind of hold that and kind of do it like a collection later. What would be the opposite of at least? Instead of at least meaning the minimum, we could say at the opposite, at most. At most, you could get 100%. That means you could get 100% or you could get less. So just kind of thinking about the words and thinking about what symbol it is. So I just put a couple of sentences up here and see if we can use those sentences to get an algebraic inequality, not an equation, but an inequality that helps us understand. So let's look at that first one. During hibernation, a garter snake's body temperature never goes below 3 degrees Celsius. So since we're talking about temperature, I'll put a T on one side. Temperature is never below, and I know the number I want to talk about is 3. I don't want to put the degrees C on there. I know that's my units, but I might get confused that it's another variable, so I just want to leave the units right now. What would it be? Can the temperature, so I have to decide, can the temperature be more than 3 degrees Celsius?
Yes.
Yes, it can be more than, right? So I know I have the greater than. So it never goes below, but it can't be less than 3.
Right, but it can be 3.
It could be. It just says it can't go below, but it didn't say it couldn't be 3. So I would put the equal sign. And usually when you draw it, you kind of like make this a little flatter and do it like that. So it's like a smash of the equal sign and the inequality together. So then I just substitute some numbers in just to see if it does make sense. If I put in 4, would that be true? 4, if body temperature could be 4. 4 is greater than 3, so that works. Now, what they ask you to do is to graph the solution. Now, in the last chapter, they asked you to graph a solution. And if the solution, like to this problem, a plus 2 is 3, what's the solution here? What does a have to be?
1.
A can only be 1. So when I graph that, it's so silly. I always thought it was silly because I'm like, okay, let me graph it. Wait for it.
Yeah, it's
1. I couldn't find any words 1. So this graph never made much sense to me because it didn't get much more information, and I did a little more work. If I'm going to do more work, like put something on a graph, I want to get some information for it. So let's graph this solution though. And since I'm going to graph the number 3, and I can zoom in on the number line wherever I want, I'll do 1, 0, 1, 2, and then I'll put a 3 here, and I'll put the 3 on there. So now I want to show numbers that are greater than or equal to 3. So I want to graph with my number. I'm going to put a circle around 3 for right now. I always start with a circle. And then the temperature can be more than 3. So that would be all the numbers here. Anything to the right of 3. And can it be 3? We talked about it being 3. So since it can be 3 as well, I'm going to color that in. If it was only less than 3, I wouldn't color it in. I would just say everything but 3. Now, this graph told me some information. Because any number you tell me now, I just have to decide, where is it? Does it fall over here? It's true. Every number, and the reason it's aligned, it tells me there's an infinite set of numbers, because the it could be 3 and 1/10, or 3 and 1,000,000 tenths, 3 and to the millionth power. It could be anything in here, any number in here. I could break that number apart, not just whole numbers, right? It's any of the numbers in between. It could be a 3 1/3 or 3 1/100 of a degree. It could be any of that.
So any rational number.
Any rational number. Sometimes.
Oh, and irrational too, right? Irrational numbers. No, rational.
I have to think about the irrational.
Could it be like 3 1/4?
Yes.
Yes, so it's not just the whole numbers. That's why that line makes a lot of sense, because it could be, we could have a part of a degree, right? It doesn't have to come in a whole degree.
Yeah,
So
it's all the fractions and all the decimals that fall between 3 and 4, 4 and 5, 5 and 6, 6 and 7, 7 and 8.
all the way up to whatever temperature you could imagine. Okay, so now sometimes I have a different scenario, and sometimes I might just have something like this. It's not a real life scenario, but for right now it helps us practice a little bit. The sum of 2 and y, I might have, say, the sum of greater than or equal to 3. Y might stand for something else, and I might have just put the y. So the sum of 2 and y, sum tells me to add it. The sum of 2 and y is greater than, I know it has that is, but the greater than is bigger. Greater than or equal to 3. Now,
So it could be anywhere from 2 to infinity.
from 2 to infinity, would 2 work? If I put 2 in here, 2 plus 2 is 4, okay?
It
Well,
could be 2 plus 1.
Does it have to start at 2? Could it be a number less than 2? Could y be less than 2?
If it's 2 and 1 and 1/100.
So between 2 and 3, right? It could be anything between 2 and 3. So when I want to solve this one, and I mean, if we were thinking about it with the whole number, you could already see what y should be. I'm going to solve it just like I would solve a whole number. So I want to subtract 2 from this side of the inequality, and I want to subtract 2. I'm still going to do the same when I do to one inequality. I want to do that because I want the scale exactly tipped. I don't want to change how the scale is tipped. I want this side always to be more than this side. I don't want to shift it around. So on this side, I'm left with y, and on this side, I'm left with greater than or equal to 1. So you were right, it could be 2, but it could be a number between 1 and 2 as well, and then of course anything bigger. So again, if I want to graph that, the graph has a little more meaning to me now. And so if I want to graph that, I'll start with, I'm only going to go to 1 is where I want to go, so I'll start with 0, and I'll put 1 here, and I always like to put one number on the other side of it. So y then could be 1, and it could be everything greater than 1. So it could be 1, it could be as small as that number, or it could be as big as, I don't know, it could be as big as 10 to the 205th power too, right? It could be anywhere and anywhere in between, and even
If it's 2 plus 1, it's 3, and it says the sum of 2 and y is greater than.
Greater
or
or
equal to.
because it's equal to, you're right. So if it was just greater than, I would have had to leave the 1 open and said even just a little bit bigger than 1 would still count. So that's why I still would leave it open and let the graph go.
Right.
Let's try it one more. Temperature in February was at most 6 degrees Fahrenheit. So temperature, and I have 6 over here. Again, I'm gonna leave the units off just because I might think it's another variable. I don't wanna do that. Was at most. So what symbol would show at most?
It would be less than.
Right, because it couldn't be 7, right? So I'm thinking if I put 7, so it would be less than. Could it be equal to?
It cannot be equal to.
It was at most 6 means that
So then it can be.
this one, it means it can be. So that's like the little thing we're getting a little practice on seeing if it does. So then I would graph that one again pretty easily. Then I have a question for you. I have a pondering. Okay, since it's a 6, I could start with 0. But I don't feel like I want to do that much work, and I really don't have to. I'm going to do 6. All I have to do is put one number on either side. That's all I need. Especially if that number was like 100, I would not start at 1 and start numbering it up. 6, it's Friday. I don't think so. So circle the 6 while I'm thinking about it. Less than, what I really do like is this does point the way. If the variable's on this side, it does point the way we're going to go. And now we said it could be equal to, so I have to color it in. If it was less than, I would leave it open. Now here's my wondering. Well, do you wonder anything? Let me ask that. Do you have any wonderings?
Why do you put the line underneath instead of just drawing an equal sign as well?
I don't know why this wasn't the less than or equal to. I always wondered it myself. Maybe it was just too much work. I don't know.
Because mathematicians, she says, always write as little as they can, as little as they have to.
They use that part as part of the equal, and they're just. I always
answer something else.
That was a great wonder, because I always wondered that myself.
It's a great wonder.
Let me ask you this. If I had something that said A equals 2, can you see okay?
Yep.
Yeah.
2. I could write 2 equals A, right? I could switch it. A is 2, 2 is A. I could switch them around. Can I do that same thing for inequality? Can I say T, let's just do less than. T is less than 6. Can I say that that's the same as 6 is less than T? Can I switch them around?
No.
Why not?
Well, T is less than 6. 6 is less than T. So they would really be equal then.
If that was true, it would really be equal, right? Why wouldn't this work? Can you think of, all you have to do to say you can't is find one time when you can't. To say that you can, you have to find all the times you can. So it's always easier to prove something that can't be done. What's an example where this wouldn't be true?
If T is 5.
So what is 5? Say 5 is less than
6, but 6 isn't less than 5.
Not less than 5, right? That's not true. So I can't do that. If I am going to change the position of the, if I'm going to change these positions, I have to change the direction of, that's a good point, the direction of the inequality. So I can read this as saying, I can read it this way, saying T is less than 6, or I can read it this way, saying 6 is greater than T. But I have to read it a certain way. So sometimes they might say, write 2 inequalities. Good, here's one. What's another one I could say? T is less than 6, or I could say 6 is greater than or equal to T. So I just changed the order, but I have to change the order there.
And those are some wonderings about inequalities.